Good day, guys. I'm back again. Today is doing chemistry today, and let's not forget tpaths tutorial, please. Now, I had to sit back, and think of something. And what came to my mind was that when I observed the years of the past questions, and I observed that a good area of question is gases. And I tend to ask myself, everybody know about gas. What if you look at it at what problems involving gases? That are those questions that you might really have issues in. We want to see one way in which we can teach everybody and everybody can understand it. Because if you observe the values of those parameters in gases, that's something you can really place a calculator. So they more of like prompt such questions in JAM. And that is why we do, more importantly, let everyone know, please, when studying for chemistry in the exam, you need to know about gases. You need to understand the concept about gases. You need to understand gas laws. You need to understand every one of them. Very, very important. Gases. We learned again that some of the values of gases is the fact that gases have what they call weak intermolecular forces. That's one of the things that prompted to what? You observe that gases, what? They take the shape of the container. They take the shape of the container. And that's why you need to observe that gases, you can see that it can be measured using various instruments. You can hear that the gas pressure is measured with this, measured with manometer, measured with barometer, measured various instruments under gases. And that's why you need to know. But more importantly, we believe that all gases all gases involved, we need to know about them. We need to just recall because some of those things come out as what questions. Example we need to know is that you need to know that gases itself, if you consider gas, let's consider a gas chamber, something like this. We observe that each molecule of the gas do not exert either attractive or repulsive forces. They do not exert either attractive or repulsive forces. This is one of the postulate, or like I say, the kinetic molecular theory of gases. They do not exert either they do not exert either attractive or repulsive forces. Again, we need to know that these gases here, they all are said to be what? Point masses. They are all said to be point masses. And that is the reason why you observe that gases have what they call negligible volume. Negligible volume. That is why we need to know that the cylinder itself, that if you have a gas chamber where consists of the gas molecules, we believe that the volume of the gas is the volume of the container only. We don't take care of the molecules. So we assume that it's only the container that takes part in what that contributes to the volume of that system. Also, we need to also note about gases that gases, you can see the whole movement is in rapid, is in random, and you need to know that is what it travels in a straight line. One of those easiest experiments that is being done is in the lab is when you take a torchlight, probably in a dark room, you hold your torchlight, you see the rays going in a straight line. Now, we're going to now need to know that in gases itself, we need to know about what they call gas laws. Fine. You need to know that gas laws are the Boyle's law, the Charles law. Yes, you know about all this, but do you know how to apply them? Do you know how to solve questions? Do you know about the necessary things that must be done when dealing with gas laws? That is why we are here today, to discuss about them. We are here today because we want to learn how to do them very, very well. Please, ladies and gentlemen, all these concepts I've been doing so far, try to solve questions. It helps. Now we are going to be looking in gas laws, looking at problems in gas laws. So please, this is like a check. So even though you feel that okay, this is similar, that's why I have to bring it up from your past questions. So not bringing it from somewhere else, from your past questions. So you can get familiar to all these questions. So let's start the first question. Question one there. The first question there. They said that is question one. You can see the one you got it from 1991, number 5. 1991, number 5. It said 30 cm cube of oxygen. Wow. The volume is what? 30 cm cube of oxygen. At 10 atmosphere, pressure is 10 atm. Is placed in a, so that means it's a P1, it is P1, B2 is equals to 20 dm. Calculate the new pressure if P2 if temperature is kept what? Constant. If temperature is kept constant, we can kept what? Constant. And we need to that we call that P1 V1 is equal to what? P2 V2. Ladies and gentlemen, we need to know before solving first, guys, you need to know that the unit. Look at the unit. B1 is in cm cube, B2 is in what? dm cube. Something is wrong somewhere. We need to know. And we can recall that what? 1 liters or 1 dm cube is equals to 1,000 mil. So if you have 20 dm cube, that will be 20 dm cube will be equals to mil is also the same as saying what? Cm cube is equals to what? X. So X is equals to 20,000 cm cube. That is it. So we can also now P1 going to P2 V2. So we convert 20 dm cube to cm cube. You can also put this in terms of what? Dm cube too. So, but if we are doing P2, it will be equals to P1 V1 over what? P over V2. What is the P1 today? 10 times 30 over 20,000. This is like you're saying 3 over 200. 3 over 200 is, I have my calculator here today to make life easy. That is what? 0.015. 0.015 ATM. The answer, oh, is not there. But let's look at it. I think there's a typo there. 30 cm cube, 20 dm cube. I think this should be in dm cube. If this is in, if it's in 30 dm cube, this attempt, let's see something. So we have that P2 now will be equals to what? Will be equals to 10 times 30 over 20. So this is what? 1 point. This is 2 in, okay. 10 times 3 is what? 30. 30 over 2 is what? 15 ATM. So I think the question, the typo is in DMQ. So any of them, we've answered it very well. So that's option what? B. The next question, they said a sample of gas exerts a pressure of 8.2 atm. The pressure is what? 8.2 atm. When confined in a volume is what? 2.93 dm cube. When confined, so 2.93 dm cube container at temperature is 20 degrees Celsius. Guys, when you see Celsius, don't wait. Convert to Kelvin. When you convert to Kelvin, you add 273. And that is what? 293 Kelvin. When I have that, the number of moles of gas is unknown. But luckily for us, they're giving that R is equal to 0.082. 0.082 liter atm degree per mole. Now, guys, you have our data. This makes life very, very easy for us. We have our what? Our data. That is the case. We can easily, let's quickly, we can now solve. We can solve. So we recall the ideal gas equation. That is PV is equals to nRT. So we are looking for what are we looking for here today? We are looking for the temperature. Okay, we have temperature. We are looking for the number of moles. The number of moles is equals to PV over RT. And what's your pressure today? 8.2. What's the volume today? 2.93. R is 0.082 times what is the temperature? 293. So you do the math there. Let's see with our calculator what happens. So we are pressing our calculator to see what the answer will be. So we are having 1 mole. 1 mole. 1 mole. That is like you saying option E. Option E. The next question, 1992, number 6. If 100 cm cube of oxygen pass through a porous plug in 50 seconds, the time taken for the same number of oil, for the same volume of hydrogen to pass through the same porous plug is dash. Ha! This is a very good question, guys. Let's recall some things. I want to build some derivations, and let's recall some things. Let's recall that this is ground of derivation. R1, R2 is equals to M2 over M1. But this one, R1 is means rate, and rate can be assumed to be what? Volume over time. If you are doing V1 over T1 times T2 over V2 is equals to square root of M2 over M1. Guys, this is a constant volume. They said constant volume, same volume. So that means it is what? You can say it is T2 over T1 is equals to what they call square root of M2 M1. Let's assume that the first gas is what? Is oxygen gas. If the first one is oxygen gas, the second one is hydrogen gas, let's do the math. So the first one is what? So this is T of what? O2 over T of H2 is equals to M of H2 over M of O2. Let's do it now. So if 100 cube of oxygen pass through a porous plug in 15 seconds, but the time of oxygen gas is 50 seconds. The time taken for the same volume of hydrogen, so T of hydrogen is unknown, is equals to the M2 is what? That is 2 over 32. 2 here, 1, 2 32 is what? 1 over 16. And 1 over 16, square of 1 over 16 should give us what? 4. Should give us, okay, not 4. So square root of 1 over 16 give us 0.25. So you are now saying 50 over TH2 is equal to 0.25. And we can now say that TH2 is equals to 50 over 0.25. So 50 divided by 0.25. That is 200 seconds. Let's look at something there, because the unit there is getting so much. Now let's take of oxygen gas, 100 cm cube of oxygen pass through porous plug in 15 seconds. C of oxygen gas is 0.1, that is what? 100, 50 rather, 50, 16 times oxygen gas is O2, 16 times 2 is 32. 32. The time taken for the same pool of hydrogen, the time taken for the same porous plug is what? 2. Okay. Don't know the time. Okay, 50 square root of 2 in 1, 2 in 3, 160, 1 over 60, 0.25. So 50 over 3H2 is equal to 0.25. Okay, we can calculate that the answer is not there. So we are having 200 seconds. 200 seconds. 200 seconds. So sometimes it happens like that. It happens like that. Next question. At 25 degrees Celsius, so you can see clearly, write your data, write your data, write your data, write your data. Write your data, write your data, write your data. I said, yeah, at 25 degrees Celsius, the temperature is 25 degrees Celsius. And 1 atm, pressure is 1 atm. A gas occupies a volume of volume is 1.5 dm cube. What volume will it occupy at V2, V1, V2? At T2 is what? 100 degrees Celsius. This is T1, P1 at 1 atm. So it is a constant pressure system. A constant pressure system, this is what? Charles' law. Charles' law. So with Charles' law, we recall that V1 over T1 is equal to V2 over what? T2. So V2 be equal to V1 T2 over what? T1. What is your V1 today? 1.5. What is your T2 today? Your T2 is convert to Kelvin. That is 373 Kelvin. How did I get 373 Kelvin? I added 273. Done this convert to Kelvin, this is 298 Kelvin. So times 373 over 298. 373 divided by 298. 1.88 1.88 dm cube. 1.88 dm cube. That is answer option A. Option A. The next question there, they said 8 grams of CH4 occupies mass is equal to 8 grams, occupies volume is equal to 11.2 dm cube at STP. At STP. What volume would 22 grams of what volume M is equal to 22 grams? This is the first one is CH4. The second one is what? CH3, CH2, CH3. Occupy under the same. What volume? So V2 is unknown. Wow. It's a very nice question. Let's look at it. Let's say because our PV is equal to nRT. We can say PV is equal to what? Mass over molar mass. Abi? RT. They said at STP. If it's at STP, that means pressure will be 1 atm. Volume is 11.2 dm cube. Okay. So if we're looking at STP, we don't know what V2, but not at V2. V, not V2, rather V will be equal to M over molar mass RT over P. At STP, pressure is 1 atm and temperature is 273 Kelvin. So we can solve. So if that is the case, we can solve. So our volumes unit is in GMP. So we have to use 0.081. The mass here is 22. What is the molar mass of this? 12 plus 12, 1, 2, 3. That is 12 times 3, 3, 5, 7, 8, plus 8, plus 8. Less than 3 is what? 36. 36 plus 8 is what? 44 grams per mole. So this is the molar mass. So 22 over 44 times R is 0.082. Times your temperature is what? At SCP, temperature is 273 Kelvin. And at SCP, pressure is 1 atm. Let's do this math. So 22 times 0.082 times 273 divided by 44. 11.193. 11.193. See? Option B. 11.2 dm cube. Approximately. 11.2 dm cube. So guys, we know when you say a question in gases, don't feel I cannot solve it. Attempt it. Attempt it. Try it. There are good area of questions in gases. So always practice more questions. And if you see a question that you are having difficulties in, try to go back to your notes. And what? Go through it again. Very, very important concept you need to know. The next thing we need to consider here is next question. They said 1994, number 5. They said to what temperature must a gas? T1 is 273 Kelvin. To what temperature? That means T2 is unknown because they said to what temperature be heated in order to double both its volume and pressure. That means P1, P2, V1, V2. So you know this is P1, this is V1. So to double both its pressure and volume. So this is what? 2P1, this is 2V1. Beautiful question. What do? We recall our combined gas law. Combined gas law. P1 over V1 is equal to P2, V2 over what? T2. Therefore, T2 will be equal to T1, P2, V2, P1, V1. What is our T1 today? 273 times 2P1 times 2V1. over P1 B1. Wait. So 273 times 4. 273 times 4. That should give us what? I think that you want 1092, Sha. 273 times 4. Yes. 1092 what? Kelvin. Guys, you see the way you are breaking it down this question. He said to what temperature when the pressure and volume is doubled. So if it is doubled, it means twice the initial value. So if, for instance, if the pressure is 4 atm and you add that the pressure was doubled, therefore P2 be what? 2 times 4 atm. So you need to know when you see what questions like doubled, tripled, halved. You need to understand questions like that. So let's continue, please. What volume of oxygen will remain after reacting? Gay-Lussac's law. This is Gay-Lussac's law. For those that come on Gay-Lussac's law, this is a very good question there. Let's see how we can solve it. So they said, to what volume of oxygen will remain after reacting 8 cm cube of hydrogen with 20 cm cube of oxygen? The first way of forming this question to be correct. If you don't do that, the question, you might not get the right answer. So what you first do is to write a balanced chemical equation. That is H2 plus O2 is giving us H2O. So this is 2 and this is 2. It is balanced. It is balanced. So they said, what will oxygen will remain after reacting 8 cm cube of hydrogen? So, sorry, 8 cm cube of hydrogen with 20 cm cube of oxygen. What volume of this will remain? What volume of this will remain? So that means if I'm reacting 8 cm cube, this will be what? Let's say I don't know what is this. Not put one part of it in case you don't know it. But this is what we call 2-to-1 relationship. But if you don't know it, just like this. 8, you give me 20. 8 is giving me what? 8 is giving me 20. Sorry. 2 moles of H2 is equal to 1 mole of O2. Therefore, 8 is equal to what? X. What am I? X is equal to what? Because X is equal to 2x is equal to 8. X is equal to 4. So because if you have 2 moles of this one, it means you'll be half of this. That is 4 cm cube. And here will be what? 8 cm cube. So I want to be the amount remaining. You divide, you subtract, you get 16 cm cube. You get what? 8 cm cube. This is the gas remaining. For O2 is 16 cm cube. For H2O is called 8 cm cube. You look at your question, you can see option D. But what if in the question, this is a very popular question in the JAM. What if you're now asked, what is the residual gas? What is the residual gas? Therefore, the residual gas will be this plus this. That is what? 24 cm cube. The total volume, that is residual gas, 24 cm cube. Let's continue next. A gas sample, see the question that is, see how the question is coming? A gas sample with an initial volume of 3.25 dm cube, a gas sample with an initial volume of 3.25 dm cube is heated and allowed to expand to 9.75 dm cube. Is heated and allowed to expand to 9.75 dm cube at constant pressure. What is the ratio of the final absolute temperature? So a gas sample with initial volume, so V1 is 3.25 dm cube. V2 is what? V2 is 9.75 dm cube. So we're now asking what is the ratio of the final to the initial. But with this, the way we can relate this together is Charles' law. That is V1 over T1 is equal to V2 over what? T2. So let's go and multiply. V1 T2 is equal to V2 T1. And what is your V1? 3.25 T2. And what is your V2? 9.75 T1. So divide both sides by 3.25. That is T2 is equal to 9.75 over 3.25 T1. So what is 9.2? 9.75 divided by 3.25. That is 3. So this is 3. So this is what? T2 ratio 3 to 1. So the answer is what? 1 ratio 3. 1 ratio 3. 1 ratio 3. Or you can do it like this. T2. Or you can do it like this. T2 is equals to, if T2 is equals to 3 of T1, you can see that it is what? Divide both sides, you can see it is what? C2 over C1 is equal to 3 over 1. 3 over 1. So that is, you can also say is what? You can say it is 3:1. 3:1. 3:1. Another is 3:1. Option what? A. Option A. The next question there, you said that we are told that a mixture of 0.2 mole of argon, 0.2 mole of N2 and 0.3 mole of H3 exert the total pressure of 2.1 atm. The partial pressure. That is a very good question, but the question is not complete. So I will just pick any one of them and explain that concept. Now, this falls under the called Taussig's law of partial pressure. So under that law of partial pressure, and we need to know that under that law of partial pressure, we need to recall that the total pressure of the system will be the sum of the partial pressures of each gas involved. Of each gas. So, what if I have, now look at this total. I have N2 and I have helium. That means the total pressure is equal to the partial pressure of carbon plus partial pressure of N2 plus partial pressure of He. Now, guys, what is the partial pressure? Partial pressure of AR is equal to the mole fraction of argon times the total pressure. Guys, please note all these things. Very, very important. The mole fraction of argon times the total pressure. Now, how can we get the mole fraction of argon? The mole fraction of argon, for instance, is equal to the number of moles of argon over the total number of moles. But then by total number of moles, that is the number of moles of argon plus the number of moles of N2 plus the number of moles of helium. Let's do that. What is the number of moles of argon today? The question, that is what? 0.2. So 0.2 over 0.2 plus 0.2 plus 0.3. Let's check my calculator. That will be 0.2, 0.3. So we're having 0.2857. It's 0.2857. This is the mole fraction of argon. Then we can get the partial pressure of argon. So partial pressure of argon will be equal to 0.2857. What is the total pressure today? The total pressure in that question today is 2.1. That means 0.2857 times 2.1. You have what? 0.6 atm approximately. 0.6. Maybe that is what they even asked. That's option D. So, guys, this is how we solve questions like that. So, you have a partial pressure system. So, in a partial pressure system, we are trying to tell us that the total pressure will be the partial pressure of each gas involved. Each gas involved, that will be the partial pressure of it. So, therefore, if that is the case, so the partial pressure of argon is equal to the mole fraction of argon times the total pressure. So, what is the mole fraction of argon? That will be number of moles of argon divided by the total number of moles. And what is the total number of moles? That is the total number of moles is what? The total number of moles is the sum of the number of moles of each gas involved. And what are the gases involved today? Argon, N2, and helium. So that we are having this. So the next one is 0.2857. That is the mole fraction. Then we cannot input and what? Solve. The next thing, he said is 30 cm cube of oxygen diffuses. So that's the one thing for you to try on your own. 1997 number 7. Try it. You can try it. The answers are there. That's why the next one, 1998 number 5. Very good question. I came that question specifically. I want to explain the concept there. So we have 30 cm cube of hydrogen was collected over water. That means volume of that. Volume is what? 30 cm cube. You can say it's V1 over water at 27 degrees Celsius. Temperature is 27 degrees Celsius. And 780 millimeter mercury. Pressure is 780 millimeter mercury. The development of water at the temperature of the experiment was the pressure of water is what? 10 millimeter mercury. Calculate the volume of the gas. P2 is unknown. At 760 millimeter mercury, P2 is 760 millimeter mercury. And temperature of T2 is 7 degrees Celsius. Guys, this is a very good question. Please, let's follow up. Now, first of all, let's convert this to Kelvin. What do? We add 273 plus 27. This is what? 300 Kelvin. This plus 273. This is what? 280 Kelvin. This is the case. Now, they are told that the hydrogen gas was collected over water. Please, how do we solve that question? This is never the final pressure. The real pressure will be the real pressure, that is P1 itself, will be 780 minus 10. That is the pressure, that is the total pressure above water minus the pressure of water. We give us the pressure of hydrogen gas. So the total pressure above water minus the pressure of water, since it's collected over water, is equal to the pressure of the hydrogen gas itself. So this is giving us 770 millimeter mercury. Now we can solve. Very good question. This is what feels a lot of students in JAM. They don't know. They don't know. You just take this pressure solve. And the funny thing is that we won't try it in 2 ways now. We try to go in 2 ways to cover some things now. We tried in 2 ways to cover some things now. I want to cover 1 or 2 things. So let's solve. So if we are saying P1 V1 over T1 is equal to P2 V2 over T2. So if V2 is unknown, so V2 is equal to P1 V1 T2 over T1 P2. What is the P1 today? 770. What is the V1 today? 30. What is the T2 today? 280. What is the T1 today? The T1 is 300. And what is the PT today? 760. This we are 0, 0, 3 1, 3 10, 0, 0. So we have 77 times 280 divided by 760. That is 28.37. So the V2 is what? 28.37 cm3. Let's look at the answer there. You see now, that is option C. Option C, 28.4 cm3. It was approximated option C. Guys, what if someone, let's look at someone like that naive. So V2 is equals to the same formula. What is your P1? 780. What is your P1? Your V1 is 30 times 280 over 300 times 760. Same thing. Go away. 3 1 is cancelled. So I left it what? 78 times 280. 78 times 280 divided by 760. That is 28.74. That is 28.74. 28.74 cm3. 28.74 is not even there in the option. 28.4 is there. So you can see now you need to know all these things. So you will know the right thing to use. The next question then. Which of the following gases will diffuse fastest? Which pass through a porous plug? Very nice question. Now you can see, guys, this question now, we know about grounds of diffusion already. We know that grounds of diffusion is what? Rate inversely proportional to the square root of molecular mass. Yes, we know it, true. But do we know how to apply it? Fine. We have various gases. Now we need to know that if we have various gases, we need to know that the smaller the gas, the higher the rate of the diffusion of the gas. I take that again. That the smaller the gas, the higher the what? The rate of what? Of diffusion of the gas. So now we have propane. Very good question. These are very good questions. We have propane. Let's see how we can analyze something like that. Let's look at it together. So we have propane. So propane, we have oxygen, O2. We have methane, CH4. We have ammonia, NH3. This is what? 17 grams per mole. This is 16 grams per mole. This is what? 32 grams per mole. Propane is C3H8. That is 44 grams per mole. The question is now asking us here, which of the following gases will diffuse fastest? Which passed when passed through a porous plug? So the one that will diffuse fastest is the smaller gas. The smaller gas is 16 grams per mole. So 16 grams per mole will diffuse what? Fastest in this what? Gas. Which of them will diffuse last? Slowest to paint. So that's a very good question. So we can see now we have 3 more questions left. I love all these questions. Yeah, I love all these questions. So I want us to note something. I skipped one earlier. Let's attempt it. So we look for a way of sending you the slide so you can also work on something like that. Now, I would like to do this question. I would want to solve 1999 number 2. 1999 number 2. Very good question. I don't like that question. They said 56 cm cube of a gas at STP. Volume is 56 cm cube of a gas at STP. Weight 0.11 gram. Weight 0.11 gram. The mass is 0.11 gram. What is the vapor density of the gas? Vapor density of the gas. You don't know it? Molar volume of the gas is molar volume is 32.4. We have that. We recall that PV is equals to nRT. PV is equals to nRT. Please follow me. So PV is equals to mass over molar mass. RT. So this is not P is equals to M over V. RT over molar mass. And what is M over V? M over V is called what? Density. So P is equal to density RT over what? Molecular mass. Or so guys, if you look at this question, I was trying to create the relationship between density and this, but there's not one way of doing it. So we have various ways of doing this question. So I will probably take this in the next class, and I want us to send the slides to you guys so everybody can go through the remaining questions that we have left. So guys, please, there are a lot of questions. Let's go and practice, please. Let's go and practice. But I really appreciate your time. So take care of yourself. Do have a nice day.